Yo, what's good, chillers? Welcome to the channel. For those that don't know me, I'm Noah. Today, we're going to be diving into Unit 1 of Organic Chemistry 1. So, the reason that I'm doing this is to keep my skills up. Don't want to get washed before Orgo 2. And yeah, see how this thing goes. Alright, first question. Consider the two compounds below, and they're bolded and underlined protons. The bolded and underlined proton of compound A is more acidic than the bolded and underlined proton of compound B. Explain why this is the case and support your answer with any other relevant structures. Okay, so the first thing that you're going to want to do when you see a question like this is draw the resonance structures. How do I know that? Because resonance structures contribute to how acidic the conjugate bases of the structures are. So, I'm going to just draw the conjugate base for compound A, which looks like this. So, just going to go in for resonance. So, nitrogen always has 3 bonds in a lone pair. So, in this case, it has 2 lone pairs, which is why I drew this negative here. And with resonance, you turn a lone pair into a pi bond, like that, and a pi bond into a lone pair, like that. And remember your double-sided arrows. It's a stupid way to lose points. Alright, next structure. So now we have a negative over here on this nitrogen, because remember we just moved it over. And don't forget to draw your other bonds. Okay, again, lone pair, pi bond, lone pair. Double arrows. Bang, 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 nope, bang, 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 bang. Okay. Again, same thing. Pi bond, lone pair. Lone pair. Pi bond, lone pair. Then we get our last structure, which I'll draw up here because I'm kind of retarded and ran into space. Okay. Now we'll do compound B. So it's pretty much the same, except this one had nitrogen over there. But take off that hydrogen because we're going to deprotonate, because it's the conjugate base that we're interested in here. So, unsurprisingly, we're going to do the exact same thing. So, lone pair, pi bond, lone pair. How about that? really gotta be a fucking artist with these hexagons. Such bullshit. Let's get some fucking music in here. It's so fucking sad and dead. What are we doing? Give me something good. Yeah. Now we're in fucking business. Let's go. I don't want it to be too loud, distracting from my glorious organic chemistry abilities. Fucking smaller. Alright, lone pair pi bond. Pi bond lone pair. Hello. Brother, that one time. I'm in love with two girls at one time, and have any of you guys ever been in love with two girls at one time? I can't say that I have. But maybe one. Who knows? You gotta pay extra to find the answer to that. My OF. Nah, I'm playing. I'm playing. Alright. So, we got, it's important, so I'm clipping the music for a sec. We got this, missing a double bond in all of these fucking structures, you retarded bitch. Alright, so we got this compound versus, let's just get it right next to it for the fans to see. Alright. Which one has the more acidic proton? Oh no, it's not that. Fuck, I'm retarded. Sorry. We're comparing the main highlight here is this. Do you know why? Probably don't, but I fucking do. The negative charge on nitrogen. If you notice, in compound B, the negatives are only ever on carbons. So that's how we know this guy over here, this guy is the more electronegative because of that. Good stuff. Question 2. Oh, fuck these. Oh my god, fuck these. Let's get music back. Man, I just want to drink aggressively. Fuck. It's music, man. Alright. So, in the molecule shown below for the bonds labeled A, B, C, and D indicate the space provided sigma or pi and what orbitals are overlapping to create that bond. Hybridization of the atoms level 1 through 5. Okay. I'm gonna opt to redraw these in a way that makes it easier to see. Okay. So this is clearly a sigma bond because why? Because it's a single bond. Kind of sounds like single, sigma, single. It's easy to remember. Okay. What orbitals are overlapping? So this carbon is sp3, this one on the left, because it has 4 electron density things, and this carbon is only sp2 because it has 3 electron density regions. So we got sp2, sp3. Nice. All right, B. Bang. All right. Oxygen, carbon, carbon, carbon. Okay. And then we got an implied hydrogen. So oxygen. So a neutral oxygen actually only has one. It only makes 2 bonds, I want to say. So sp3, sp. No. sp. Actually, I think there's no hydrogen here. And this, yeah, this is like that because it's in a ring, so it won't have that hydrogen. So this is still a sigma bond. And we got sp2, sp3. Yeah. Alright. C. Carbon. Bang, bang, bang. Carbon. Okay. So we got another sigma bond, and we got sp2 to sp. Actually, there is the implied hydrogen. I don't know what's up with B. Scratch this one. Fuck that. I don't know what's going on with that. But this one, sigma again, sp, sp3. Nice. All right, D. We got double bond carbon to a nitrogen. Again, nitrogen with 3 bonds in a lone pair. So we got sp2 to sp2. And of course, this is not a fucking sigma bond. It's both a sigma and a pi bond, because every time there's a double bond, not only is there a pi bond, but there also is a sigma bond, which is easy to forget. And a pi bond is always p to p. in terms of its orbitals, and we just said this was sp2 to sp2. Nice. Alright. What's this 1 through 5 shit? Alright. Hybridization. Can do that. So this is going to have a lone pair, sp2, 3. Nice. sp3. 2. What do we got? It's carbon. sp. Bang. Easy. Number 3. Remember, lone pair, sp2. Easy. 4. Oxygen. I guess he gets 1 lone pair, sp2. And that's that. Wrapping it up. Alright. Nomenclature. What do you do first with nomenclature? You label, you number. And you want the most substituents at the earliest numbers. So, I am going to number it like this. 1, 2, 3, 4, 5, 6. Okay. So, what do we got? We got 2 methyls, 2 dimethyl, and then we got another methyl at 3. So this is kind of weird. So if there's another methyl at 3, we got 2, 2, 3, and it becomes a trimethyl. And obviously it's a hexane because there's 6 carbons, and what we don't want to fuck up is there's the 4 bromo, and that comes first because of the B. So put it all together. 4 bromo, 2, 2, 3. Get rid of that. Trimethyl hexane. Bam. Easy. Alright. This one's freaky. So 1, 2, 3, 4, 5, 6, 7. Okay. So this is a cycloheptane because there's 7 and it's in a ring. And I'm gonna get rid of these numbers so that we don't confuse ourselves. Although it doesn't really matter because we got coming off of number 1 over here. Actually, I'll put the numbers back. I'll redo them, actually. Just make it easier. Gotta do it like this because you want the substituent on the lowest number. So you got 1. And you know what this guy is? I don't blame you if you don't, but you got to. It's an isobutyl. So we got 1 isobutyl heptane. And these things you just gotta memorize, you know. Write them down a bunch of times. Be a fucking nerd. Lock yourself up. I don't fucking give a shit, to be honest. Alright. Next we got skeletal structures. These are barbecue chicken. If you don't know how to do these, I don't know what to tell you. So we see the electrons over on this nitrogen are being attached to this boron. So let's just draw the molecule as it was. Nope, not like that. Like that. And now we got, because remember, electrons are the same as bonds, so nitrogen, and they each got, that's bad, fucking goddamn, figure it out, dude. Two, hey, the music's back. Forgot about that shit. Let's get a banger on here. Alright, one done. Easy. Easy, easy. Okay, so we got some weirdness going on here. So first we gotta draw this new thing. Then can attach nice. Don't forget your charges. Well, methyl over here. Another hydrogen. So the reason that we are positive now is because now these two electrons that were once on the nitrogen are being shared in the form of that bond right there, making it have a positive charge. And the oxygen obviously is negative because it just got two electrons from that bond. Nice. Next question. Alright, this one's kind of freaky too, because we got electrons coming off the oxygen doing weird things. This is splitting, so just do them one at a time here. This has become N2. No longer positive because these electrons from this bond are going straight to the nitrogen. Feel me? And then we have this attaching CH3 to the end there, which looks exactly like you would think it does. So then wrap it all up, just redraw it over here. CH3 plus N2. Look at that. It's just N2, guys. It's just N fucking 2. Chair conformers. This shit's fucking easy as fuck too. Alright? It's just hard to draw them if you're retarded like me, which you probably are if you're watching this video. Bang. That was good. Alright. I like to number them just so I don't confuse myself. Again, pretty retarded. Alright. Equatorial. And remember, they alternate up, down, up, down, up. So if the dashed for this equatorial was to the side, this next one is going to be down, and it's just a methyl. Okay, 3, 4, 5, 6. We got axial up, but since this one goes straight up, this one will go towards the nearest corner there. And then you got to draw the flip. So you draw it the other way. And then what you do is you rotate everything 1 over. So if this used to be 1, now this is 1, 2, 3, 4, 5, 6. And then you go back to the original. We got axial down on this first one. And then this one's equatorial towards the closest. 3, 4, 5. And then we got axial up. And to circle the most stable, it's going to be, don't forget your arrows too, it's going to be this one, because you want the bigger ones to be axial. You want the bigger ones to be axial. Oh, wait. Alright, next one. CL. Should label these. Don't get lazy. 1, 2, 3, 4, 5. Up, down, up. Draw your arrows. Bang, 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 bang. Now this is 1. CL. Yup. 2, 3, 4, 5. This will be straight down like that. Which is more stable. Where's our bigger groups? We want this one. Because of that chlorine. Alright, next one. Okay, we got CL. CH3, easy. Flip them. As you can see, I'm truly a fucking artist. Fuck that, redoing it. One. CL. 2, 3, 4. CH3. What do we got? This guy. Newman. One of my boys, his name's Newman. He's the man. Gets a bunch of box. Okay, so we're looking this way. So, we got an implied hydrogen, which I'm going to draw in, that is coming towards me, meaning on the left, because if you're looking at it, this hydrogen is coming towards, out of the page, going to be on the left, so. Oh, and also, remember, this is going to be an upside down Y, because the two with stereochemistry are on the bottom. And then it's going to be It's going to have this CH3 down here. And this guy over here with the hydrogen. Because it's going to look like this. And that hydrogen is again going to be on that left side because it's coming towards you in the page. So on the right, you want the highest energy conformation. And if you guys don't remember, when they're eclipsed, it's always higher energy than when they're staggered. So I'm just going to draw the same one in the front. Kind of fucked that up, whatever. Hydrogen, CH3. And you want the biggest ones to be overlapping each other because that's just the most strain on the molecule. Oh no, this is just a hydrogen. Yeah, okay, bang. Alright. These ones are kind of fucked, but you just gotta use your brain. It's like Gen Chem shit. So we got, no, not even. I'll start with the carbon, triple bonded to the carbon, single bonded to the carbon, double bonded to the oxygen. You gotta remember, banger. Double bonded to the oxygen. Nah, I'll draw it like this, make it easier on me. Then another carbon, triple bonded to a carbon, single bonded to a hydrogen. How about them fucking apples, dude? Nice. Okay, these ones always weird me out. So just gotta go piece by piece. So we got 3 CH3s, so 3 methyls, followed by just a C with a CH2. So that's the carbon, that's the CH2. Sorry, pointing like you know what the fuck I'm talking about. That's the C, that's the CH2, because this has 2 bonds, meaning it's got 2 hydrogens, and this has 4 bonds, this one, so it's just a C. Okay, then, okay, this is done. We're here, just a C. Double bonded to an oxygen. How do you know it's double bonded? Because I'm the fucking man. No, because it's a single carbon with no hydrogens, and it's an oxygen, and there's the oxygen, and in order for there to be no hydrogens when bonded to the oxygen, it would need to have the double bond there. Okay, then another CH2, which looks like that, as we saw before. Then another CH2, and a CH3. Bang, there it is. There's your molecule. Fuck yeah. Alright. Acids and base. So. How do you know if it's an acid or a base? The acid is the proton donor, and the base is it's got the negative charge. So, acid, base, conjugate base. It's gonna look just like the acid, but it's gonna have 1 less hydrogen. conjugate base. Conjugate acid. Alright. How do you know what it favors? You gotta memorize your frickin' pKa's, you jerk off. Do I have them memorized? Fuck no. Fuck no, I don't. Is that a problem? Yeah. Yeah, it is. What am I gonna do about it? Nothing. I'm gonna do nothing about it. And I'm gonna neglect this problem until forever and ever and ever. Nah, I'm kidding. Before your exam, brush up on them. Get your shit done. Do what you gotta do. What am I doing right now? I'm going through my emails because I know I sent myself a doc with all the pKa's. And there it is. Okay. This phenol 10. This guy 5. You do it based on the higher pKa, like the higher number, even though lower is more acidic, but don't get yourself confused. You do the bigger number. Bang. Easy. Alright, acid. Base. So they were nice over here because they gave us the same one. So don't even have to think. Nice. Plus. I'm going to draw the hydrogen just cause, but you technically don't have to, because you just don't. Okay. We got 10 over here. This is just an alkene, which is 25. And that's high as fuck. Or at least higher than the reactants. So, bang. Extra credit? You can't catch me doing that shit. Get the fuck out of here. Bang. Exam 1, done. If you have any problems, any questions, too bad, so sad. Figure it out, bitch. Hope you enjoyed, and I hope that you do well on your exam.